Hey everyone, welcome to the fifth video in our series on the reactions of chapter 9. In this video, we're going to be doing types of hydrogenation in alkynes. Okay, so just like we did types of hydrogenation in alkenes, we're going to do hydrogenation of alkynes. Okay. And we are going to do one mechanism in this video, but we're not going to worry really anything about any other mechanisms. Okay, we're going to have a couple reactions, but yeah, we're not going to worry about it too much. Okay. All right. So similar to what we were doing with alkenes, okay? Hydrogenation of alkynes is similar, right? So we have some metal in H2, right? So let's take a look at this alkyne here, this internal alkyne. And all we need to do is just put in H2 with PT, right? So, we can use PD, PT, nickel, et cetera, something like that, right? And so we just put hydrogen gas over that, right? And all that's going to do is just going to get rid of both of the bonds, all right? So this is going to put me at a alkene, or alkane, sorry, not alkene. So it's very difficult to stop just at an alkene, so that's why it's always just going to turn into an alkane whenever I use reactions like this, okay? And again, this can get rid of multiple triple bonds as well, so let's say we have this triple bond in here, and then we have another triple bond as well. So we can have two triple bonds. So this is 1, 2, make this a little bit longer so it's a little clearer. 1, 2, 3, 4, 5, 6, 7 carbons. So, 7 carbons, again, this can very easily get rid of all of those. So 1, 2, 3, 4, 5, 6, and 7. Okay, so it just turns into an alkane. All right, so that's pretty straightforward. All right, so I'm not going to spend too much time on that. All right, we just put an H2 in a metal and we get an alkane. All right. The interesting thing comes whenever we are trying to get just an alkene. Okay, so let's say we just want an alkene. So there's 3 different ways that we can get just an alkene. Okay, so I'm going to move this over so that way we can have a little bit more room here. Okay, so these are going to be the ways that we can get an alkene. All right, so the first way that we can get just an alkene is Lindlar's catalyst. All right. Another way that we can get just an alkene is nickel boride, Ni2B. And the last way is metal ammonia. Okay. So Lindlar's catalyst is going to make a cis alkene. All right. This is going to make a cis alkene. All right. So let's take a look at this really quick. So let's use this alkene here. And then, or this alkyne, sorry. And then we're going to use H2 over PD on calcium carbonate with quinoline. This PD over calcium carbonate with quinoline is Lindlar's catalyst, okay? So all of this is Lindlar's catalyst, okay? All of this is Lindlar's catalyst. So I have to have the PD with calcium carbonate and quinoline. That's Lindlar's catalyst. And so what does this do? Well, it gives us a cis alkene, all right? So I take this, turn it into alkene, and it's cis, all right? I only get this one. I do not get the trans product, okay? So this is one way that we can do it. And another way that this can be written as well. Let's use this alkyne. Sometimes it's just written as H2 over Lindlar's catalyst. It's another way that it can be written. All right. And again, it just gives me the same thing, right? So I have a cis alkene, and that's it. All right. So it just stops at the alkene. And in cases where I can't have cis, right? So this would be a case where I can't have a cis alkene. Then I just get an alkene, right? So this is a good way to take an alkyne and turn it into an alkene. So I get an alkene. All right. So pretty simple. All right. Nickel boride, Ni2b, is also a way of making a cis alkene. All right. So what this is going to do is the same thing as this, okay? The reagents are just different, okay? So I'm going to do the exact same 3 problems, okay? And we will see that they do the same thing, all right? So all 3 of these are going to be the same. The only difference being that we use H2, and instead of being palladium on calcium carbonate with quinoline, we're going to be using Ni2, B, and P2. Okay, so this is P2. We don't need to worry about what any of this means, but this is just how it's written. And what is this going to give us? It's just going to give us a cis alkene. It gives us the same thing. All right, the same thing. So nothing different. Again, H2, Ni2b with P2. Same thing. That alkene. And then again here, this can't be cis or trans, so I'm just going to make a regular alkene. So let's make this alkene. So you'll see that the difference between Lindlar's catalyst and Ni2b is there isn't one, right? So it's the same thing, all right? So nickel boride and Lindlar's catalyst are going to do the same thing. The only difference is that the reagents are different, right? That's it, okay? All right, so now let's talk about metal ammonia, all right? So I'm going to use the same alkenes, or alkynes, excuse me. I keep saying that. Except now we're going to be putting it through with metal ammonia, all right? And so with metal ammonia, all right, I have a 2-step process here. So the first step is I use something like lithium or sodium, okay, with liquid ammonia. So liquid ammonia. And then it's usually cold. It's usually at a cold temperature. So, let's say negative 78 C. And then the second step, I do a aqueous workup. Okay, so second step is just an aqueous workup. And we'll see a couple different ways of writing this. In this case, this does not give me a cis alkene. This is the only way that I get a trans alkene. All right, so this is a good way of getting a trans alkene. So now I just get a trans alkene. All right. A couple variations on this. So again, I can use lithium or sodium, and I get liquid ammonia. And usually we have ethylamine in here. So ETNH2 is typically in here as well. And this aqueous workup can usually just be like a salt. So like NH4Cl, so ammonium chloride, something like that, right? And again, this is usually at a cold temperature, right? And so in this case, I just get a trans alkene again, right? So I just get this trans alkene, okay? So I go from getting a cis alkene to getting a trans alkene, all right? That is literally the only difference. And in this case, this one can't be cis or trans, right? It doesn't matter. So again, I just get this alkene. And we'll say negative 78C. So there's a couple different ways to write this, right? So just, if you see 2 steps and lithium or sodium with liquid ammonia, and then you see something as an aqueous workup as a second step, good chance that, and you're starting with an alkyne, good chance that that's metal ammonia, all right? So just know that you're going to be getting either an alkene or you're going to be getting the trans alkene, okay? So 2 ways to form a cis alkene, 1 way to form a trans alkene. And we can look at the differences between these based off what the products I'm getting from these reactions, all right? So hopefully this makes a decent amount of sense. The last thing I want to do is just talk about the mechanism of metal ammonia really quick. So let me scroll down here and do this mechanism. We won't dwell on this too much, but I do think that it's kind of important to talk about. So it goes by free radical mechanism, which is kind of strange. So again, I'm using lithium with liquid ammonia. And in this case, I am going to be using the EtNH2 with it as well. All right. And it's at negative 78C. And then as a second step, I have some kind of workup, right? Aqueous workup doesn't matter too much for our mechanism, but it does exist. And then I just get a trans alkene. So let's see how we get this trans alkene. It's kind of interesting. So the first thing that's going to happen is that this alkyne and lithium are going to react. All right, so lithium, I've just drawn one dot here. That means that lithium just has one electron. So what's going to happen is lithium is going to donate, all right, it's going to donate one electron to one of the carbons in the alkene, all right? And I've just drawn one arrow on this line because this is just donating one electron. Okay, so I'm saying this is one electron. And then that means that one of these bonds has to break and the electrons are going to go onto this carbon. Okay, so now let's take a look. So what's going to happen is these electrons here are going to form a negative charge. And then I have my free radical over here. Okay, I have the free radical over here. And then what happens now is that this negative charge is going to be able to take a hydrogen off of this, right? So I have this ethylamine here. So ethylamine is going to get a hydrogen taken off of it by this negative charge. Okay. And so that means that I'm going to get this. So now I have a hydrogen here and this free radical. And you'll notice that this free radical and this hydrogen are trans from each other, right? So this is how I'm setting up the trans reaction, okay? And, you know, in this step, I made an Li plus. I didn't draw it, but I made an Li plus. So here I made a EtNH minus, right? So then this has 2 lone pairs on it, okay? So I made that. So that's going to bind with the Li plus eventually. But so now what's going to happen is another lithium is going to come in with 1 electron, and it's going to donate the other electron to this, okay? So to that. And then, so that's going to give me a lone pair there finally. So now I'm going to have 2 electrons there. So now I have a negative charge, and all that's going to happen is another ethylamine is going to come in. Let me redraw this a different way. So another ethylamine is going to come in, and the hydrogen is going to get taken off. And then that gives me my final product, which is my trans alkene, right? This and this are the same thing. And then I also have this negatively charged molecule there, okay? And both of these negatively charged molecules I made are going to eventually bind with Li plus that I made. Okay, so I also have made 2 Li plus, all right? So this is how I make my trans alkene, all right? So not too bad, but just kind of wanted to get this mechanism across because I think that the way that this goes is kind of interesting, all right? And I've noticed that I did not draw the double bond there. Sorry about that. So that double bond stays, right? Because it didn't go anywhere. So So hopefully this mechanism is not too bad for you. And I think that it's just important to know the different types of hydrogenation of alkynes. All right. And I wouldn't worry about this mechanism too much, but I do think that it's interesting. So hopefully this video was helpful, and I will see you in the next video.